Hey there, welcome to a video regarding sections 1.1 and 1.2 for Algebra 2. This is the first video of the school year, and this is Mr. Almashni, and I have a pleasure of sharing these videos with you guys, and we'll be doing this pretty much after every class meeting. You'll watch a video for homework. Just a few things about me. I'm year 14 here at Sycamore Prep. I've been married for 4 years. I have a almost 2-year-old son. His name's William. This summer, my wife and I went to Portugal for a 1-week vacation, and I strongly recommend it if you get a chance to go. Anyway, so that's enough about me. Let's actually talk about section 1.1, properties of real numbers. So if we read here, throughout the course, we'll work with different kinds of number sets. Primarily, we'll be working with whole numbers, integers, rational numbers, irrational numbers, and real numbers. And note that some of these sets overlap with other ones. Okay, so anyway, let's talk about what whole numbers are. Whole numbers are the following: 0, 1, 2, 3, 4, 5, 6, 7, and so forth. So they always start with 0. And you go up by 1. So that's all that's happening there. Now, integers include whole numbers, but also have negative values. So we don't know where to start because usually it starts at negative infinity, but you have -3, -2, -1, 0, 1, 2, 3, comma, dot, dot, dot. So they're like whole numbers, but they're a little bit more inclusive because they don't just have 0, 1, 2, 3, 4, 5, 6, 7, 9, 10, and so forth, but also have -1, -2, -3, -4, -5, all the way down to negative infinity. So those are integers. So whole numbers are kind of like the base, and then the integers kind of build up from that. Now, rational numbers is building up even more. If you look at the first 5 letters, ratio, so it's a ratio of integers. For example, 1/2 is a rational number. Or you could write as 0.5. Both those are considered rational numbers. Also, you can think of it as a number that terminates or repeats. So, for example, if you have 1/3, if you put in the calculator, 1/3 is 0.3 repeating, so it just goes on forever. So that also would be a rational number. The bottom line is you have a ratio or fraction of 2 integers. 1 and 2 are both integers. That's what we got. Now, irrational numbers are numbers that don't follow that pattern. So some examples of irrational numbers would be like pi or √2. You can't write those as a ratio of 2 integers. But again, rational numbers, as we say, like 1/2 or 1/3, or even the number like 5 itself would be a rational number. They could be negative, so I could have done that as well if I wanted to. So the bottom line is rational numbers are ratio of 2 integers, irrational are not. And usually pi or √2 are good examples of irrational numbers, or you can also say like √3. So basically square roots of non-perfect squares. We will see some other ones later in the year. There's a number called e, and also like cube roots or other kind of roots. Things you haven't learned yet, don't worry about it. We'll get there later, and I'll have that discussion with you guys at that time. Now, a real number is kind of at the top of the food chain. It's very inclusive. So basically, any number you could think of, excluding imaginary numbers, but we'll talk about imaginary numbers later in the year. So if I kind of consider a Venn diagram, so say I got whole numbers right here. So integers include whole numbers, but more. And then, or actually, I should probably redraw that. There we go. That was actually pretty bad. All the whole numbers are in the set of integers. And then all the integers are in the set of rational numbers. and then all the real numbers, or all the whole numbers, all the integers, all the rational numbers are all part of the real numbers. So it's basically just like building up process, if you want to think of it that way. Next, we're going to talk about how to rank numbers. So if you're familiar with the sign chart, the number line, and usually we like to put 0 right smack in the middle. And I'll put like 1, 2, 3, 4, 5, -1, -2, -3, -4, -5 for each tick mark. Then let me change colors for the contrast. So -2 is going to be right there. Now root 3, hopefully you can recognize root 3 is between 1 and 2. The reason why is because root 1 is 1 and root 4 is 2. So naturally root 3 would be between root 1 and root 4. -10/3 would be a little bit to the left of -3. 2.1 I think is pretty obvious, is right there. Root 7 would be a little bit more than 2 and less than 3. Probably right there. And one way to think about it is like we did for root 3. Root 4 is 2, root 9 is 3, so root 7 is 13/4 is a little bit more than 3, so we'll probably go over here. 0 we already took care of. And the last one is -root5, which is probably, and I'll maybe do a different color, let's do black, right there. And the reason why I'm going to put it between -3 and -2 is that -root9 and -root4 will be to the left and to the right respectively of -root5, because you get -3 and -2. So what I suggest you do is pause the video, try number 3 on your own, and then after you're done, hit play and see if you get the answer. Okay, hopefully you hit pause and you hit play now. So that's what you get. -4 is the least, root 2 is the greatest, so that's how you rank them. Now we're going to talk about conversions. This will be pretty important when you get to chemistry for those who are sophomores. A lot of it is looking at rates. Rates are when you're dividing stuff. So for example, if you want your hourly wage, or how much money you make per hour, so basically you're taking money divided by time. So it's $60 divided by 5 hours, which would be $12 per hour. Or if you're looking at distance, that's 50 miles per hour. How many miles over 4 hours? So this is a proportion. That's one way you can treat it. We have two ratios of equal value. And of course, if you work it out, you should get 200 hopefully. Which kind of makes sense. If you're on the road for 4 hours, going 50 miles per hour, 4 times 50, you get 200. Now in this case, we're looking at conversions. And usually if you travel to another country, we're kind of unique where we like to use miles, but most of the world uses kilometers. So let's say you have to, you might remember the game Pokemon Go. I knew that was a fad and it was not going to last long, but anyway, that was about 2 years ago, I think. But you walk 5 kilometers, hatch an egg, playing Pokemon Go. How many miles is 5 kilometers? Well, 1 mile is 1.61 kilometers. So what you could do is, like we did in the previous problem, set up a proportion. For X miles. Then you can cross multiply and solve for X. You will need a calculator for this one. But if you do that carefully, 5 divided by 1.61, we do get about 3.1 miles. So you hear someone running a 5K, it means they're running about 3 miles, or 10K, be about 6 miles. Well, what about 2 kilometers? Well, so 2 kilometers, now what you could do, instead of setting a proportion, if you don't like doing that, you could also multiply 2 kilometers by this. 1 mile for 1.61 kilometers. So I'm still dividing by 1.61, but just a little cleaner way of doing this. So it's 1.24 miles. And 10 kilometers, of course, is this. Now, if you so wish, you could cheat, which is not a problem, because that's what we do these days. We try to be efficient. I'm not cheating, but if you want to say 10-kilometer conversion, Google has a very nice way of doing that. So you could do that if you like. Okay, so I'm back. Okay, so let's take a look at 20 kilometers per hour. We'll convert that to feet per second. So if I do that correctly, 20 kilometers per hour. So first I want to convert the hours to seconds. Hopefully you realize that's 1 hour, 60 minutes, 1 minute, 60 seconds. Why am I doing that? This is called dimensional analysis. Dimensional analysis is when you're crossing off units, so you get the desired units in the location you want. And for kilometers, we know that there's 1.61 kilometers per mile. You saw it in the previous problem. And for every mile, I gave you the conversion, 5,280 feet. So you don't have to memorize these, by the way. I'll give them to you because these are really hard to commit to memory. And again, people just use Google to look stuff up. But that's what we're going to multiply out, 20 by 5,280. And then, of course, divide by 60 times 1.61. And you should get about 18.2 excuse me, feet per second. So if you're looking to do that conversion, that's what would happen. And again, we can go to Google, kilometers per hour converted to feet per second. Let's see if Google does this for us. And there you go. It does give it to us. So Google's kind of nice that way. But keep moving. So maybe try this on your own. You want to convert 16 years to seconds. So go ahead, pause, and try it on your own. Okay, hopefully you pause and try doing this. Notice I convert the years to days, 365 days in a year. Of course, there could be a leap year, but whatever. We'll just say 365 days per year. 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. So you multiply all that together, and you get a really big number. 504576000. So you get over 500 million seconds in a year. Sorry, in 16 years, my bad. So most of you guys are 16 years old. You've been alive for over 500 million seconds. Congratulations. I'm 40, so I've been alive for over a billion seconds. So good for me, right? So, or 1.5 billion seconds. Let's see here. Properties of real numbers. So this is some leftover part of 1.1. Might be in 1.2. I'm not going to expect you to totally remember these. Sometimes I forget what commutative associative are, but just know that you can switch the order of addition. Doesn't matter. Likewise, multiplication. So like 2 plus 3 is the same thing as 3 plus 2, right? 5. Or 2 times 3 equals 3 times 2. They're both 6. So no big deal there. Associative property, if you have like parentheses around two numbers being added and you're adding another number, you can move the parentheses around if you like. Likewise, multiplication. Just keep in mind these don't apply to subtraction or division. Just by the nature of the way subtraction and division work. you can't use those properties. Identity is pretty obvious. If you add 0, the number stays the same. If you multiply 1, the number stays the same, so it maintains its identity. Inverse is when you're doing the opposite. So like if you're adding a and negative a, then they go away. If you're multiplying a by 1 over a, they also cancel out. Another big one is distributive property, which is very, very important. And as the name implies, like if you have 2 times 3 plus 4, you're at liberty of distributing the 2 to both the 3 and the 4, then multiply out and get 14. Or if you so wish, you can add the 3 and 4 together first to get 7. 2 times 7, you still get 14. But this is a very useful strategy, especially in doing with algebraic expressions like we have for number 5 here. So what would I do to simplify this expression? I probably want to distribute. And I probably want to combine like terms. So I distribute, easy, 8y minus 24. And be careful here, negative 2y plus 12. Negative 2 is multiplied by y, negative 2 is also multiplied by negative 6, so please be careful. Combine like terms, 6y minus 12. You've now simplified that expression. These are the building blocks we're going to need for stuff we do down the road. Again, we'll distribute 5x squared minus 10y minus 6x squared minus 8y. Combine like terms, negative x squared minus 18y, and voila, you got simplified. Okay, actually, I lied. So this is now 1.2. And 1.2 talks about the order of operations, PEMDAS. This is such a big deal. And believe it or not, I even have calculus students who botch this. I sometimes have to kind of, kindly remind them that, wait one sec, make sure you follow the order of operations. So parentheses always comes first, exponents next, multiplication next, division, addition, subtraction. Multiplication and division can be interchangeable. You typically go left to right. Addition and subtraction are also interchangeable, but you typically also go left to right. Now look at what we have here for number 6. Negative 4 is in parentheses, so it means negative 4 times negative 4, so you're squaring it, 16. But take a look at C. That's like saying negative 1 times 4 squared. So you do 4 squared, which is 4 times 4, doing the exponent. Then you get negative 16. Notice the difference between the parentheses and without the parentheses. The negative inside the parentheses means we had to multiply negative 4 by itself. But when there's no parentheses, just a negative and a 4 squared, it's equivalent to saying negative 1 times 4 squared. So then you square the 4, then multiply negative 1 afterwards, following the order of operations. B is the same thing as C. You have 4 in parentheses, so it's negative 1 times 4 squared, which is 16. And D also gets us negative 16. So just be mindful of where the exponent is, where the negatives are, and so forth. So let's try a few of these. So we'll wrap up these notes. For this one, you have 1 plus 49 times negative. Let's take care of the parentheses and then the exponent. And I'm not going to attempt to do that in my head. So it's 1 plus negative 735 because you have to multiply. You get negative 734 when you add to the end. For here, it's negative 5 minus 8 plus 2 minus 3 times negative 5. So we do multiplication, negative 5 minus 8 plus 2 plus 15. Then typically we move from left to right just to be clean. Negative 5 minus 8, negative 13. And I guess I could add 2 and 15 together to get 17, so I get 4 for that one. And I do expect you to know how to do this without a calculator, except for something like part A where 49 times negative 15, I'd probably use easier numbers than that. But part B you should be able to do without a calculator. If you did punch it all in the calculator and punch it in correctly, it would give you 4 because the calculator does follow order of operations. So go ahead and pause the video, try part C on your own, then we'll check in. Okay, hopefully you got 59. I'm going to double check my math. And if I remember wrong in these videos, feel free to shoot me an email or just tell me, like, Mr. I think you're wrong. I'm human. I make mistakes. I make mistakes every day, actually. My wife tells me I make mistakes that are not math related, but that's neither here or there. Bottom line is, we're human. We can make errors. So let's just double check. -1 cubed, I'm pretty sure is -1 because you have a -3 times. And 3 squared is 9, I know that. And I have a -3, 4 minus 7 squared, that's going to be +9. 16 minus 14 is 2, 2 squared is 4. Okay, and then 4 minus -1 is 5, and then I have a -3 squared is +9, but I have a minus to the left, so it's -9, plus 9, 5 and 4, 6 9 is 54. We keep moving. Yeah, we get 59. I'm pretty sure I got that one right. Now this one is involving substituting. You're going to replace m with -4. Then you're going to use a order of operations. This is what we're working our way towards, knowing how to plug in stuff into functions or expressions and working it out. So I get 3 times 16 plus 20 minus 6. Okay, cool. 48 plus 14, you get 62. Okay, I messed up with number 9. I got these notes from Ms. Wong, and I think she's a Mac user, and sometimes Mac doesn't transfer correctly to PC, and I'm a PC person, and so I think there was an issue here. So let's not worry about this problem, but we'll do practice like this in class where I'm going to ask you to look at a situation that's worked out, but there's a mistake, and identify the mistake and correct it. So this concludes the video. It's a little longer than most videos because we did cover 2 sections, but I'll try to aim to make the videos about 10 minutes long. Of course, it might take you longer to watch these or take notes because you might have to hit pause or take a break, or or maybe you didn't quite catch something I said. I talk fast and my handwriting's messy. I get it. Don't worry about it. But make sure you do watch the videos and answer the questions afterwards. The link for the questions will be in Schoology. And I will expect this to be submitted before class meets. That's part of your homework. It also helps you prepare for what we're going to do in class because we're going to do practice problems. So if you don't watch these videos or take them very seriously, it's going to make the next day really hard. And if you start getting behind, that's not good. We don't want that. So we want to make sure you're confident and staying caught up with the material. And of course, as always, shoot me an email. I check email probably 15 to 20 times a day. That's usually one of the things my wife complains about, that I'm on email a lot. So I try to limit email access when I'm at home, but I'll do my best to get back to you as quickly as I can. Okay, well, have a great day, and I will see you guys later.